Section 1.1. Use the language of algebra. Learning objectives. By the end of this section, you will be able to 1. Find factors, prime factorizations, and least common multiples. 2. Use variables and algebraic symbols. 3. Simplify expressions using the order of operations. 4. Evaluate an expression. 5. Identify and combine like terms. 6. Translate an English phrase to an algebraic expression. Be prepared 1.1. This chapter is intended to be a brief review of concepts that will be needed in an intermediate algebra course. A more thorough introduction to the topics covered in this chapter can be found in the Elementary Algebra 2E chapter, Foundations. 1.1.1. Find factors, prime factorizations, and least common multiples. The numbers 2, 4, 6, 8, 10, 12 are called multiples of 2. A multiple of 2 can be written as the product of a counting number and 2. Multiples of 2. 2, 1 equals 2. 2, 2 equals 4. 2, 3 equals 6. 2, 4 equals 8. 2, 5 equals 10. 2, 6 equals 12. Similarly, a multiple of 3 would be the product of a counting number and 3. Multiples of 3. 3, 1 equals 3. 3, 2 equals 6. 3, 3 equals 9. 3, 4 equals 12. 3, 5 equals 15. 3, 6 equals 18. We could find the multiples of any number by continuing this process. Counting number. 1 multiples of 2 equals 2. 2 multiples of 2 equals 4. 3 multiples of 2 equals 6. 4 multiples of 2 equals 8. 5 multiples of 2 equals 10. 6 multiples of 2 equals 12. 7 multiples of 2 equals 14. 8 multiples of 2 equals 16. 9 multiples of 2 equals 18. 10 multiples of 2 equals 20. 11 multiples of 2 equals 22. 12 multiples of 2 equals 24. 1 multiples of 3 equals 3. 2 multiples of 3 equals 6. 3 multiples of 3 equals 9. 4 multiples of 3 equals 12. 5 multiples of 3 equals 15. 6 multiples of 3 equals 18. 7 multiples of 3 equals 21. 8 multiples of 3 equals 24. 9 multiples of 3 equals 27. 10 multiples of 3 equals 30. 11 multiples of 3 equals 33. 12 multiples of 3 equals 36. 1 multiples of 4 equals 4. 2 multiples of 4 equals 8. 3 multiples of 4 equals 12. 4 multiples of 4 equals 16. 5 multiples of 4 equals 20. 6 multiples of 4 equals 24. 7 multiples of 4 equals 28. 8 multiples of 4 equals 32. 9 multiples of 4 equals 36. 10 multiples of 4 equals 40. 11 multiples of 4 equals 44. 12 multiples of 4 equals 48. 1 multiples of 5 equals 5. 2 multiples of 5 equals 10. 3 multiples of 5 equals 15. 4 multiples of 5 equals 20. 5 multiples of 5 equals 25. 6 multiples of 5 equals 30. 7 multiples of 5 equals 35. 8 multiples of 5 equals 40. 9 multiples of 5 equals 45. 10 multiples of 5 equals 50. 11 multiples of 5 equals 55. 12 multiples of 5 equals 60. 1 multiples of 6 equals 6. 2 multiples of 6 equals 12. 3 multiples of 6 equals 18. 4 multiples of 6 equals 24. 5 multiples of 6 equals 30. 6 multiples of 6 equals 36. 7 multiples of 6 equals 42. 8 multiples of 6 equals 48. 9 multiples of 6 equals 54. 10 multiples of 6 equals 60. 11 multiples of 6 equals 66. 12 multiples of 6 equals 72. 1 multiples of 7 equals 7. 2 multiples of 7 equals 14. 3 multiples of 7 equals 21. 4 multiples of 7 equals 28. 5 multiples of 7 equals 35. 6 multiples of 7 equals 42. 7 multiples of 7 equals 49. 8 multiples of 7 equals 56. 9 multiples of 7 equals 63. 10 multiples of 7 equals 70. 11 multiples of 7 equals 77. 12 multiples of 7 equals 84. 1 multiples of 8 equals 8. 2 multiples of 8 equals 16. 3 multiples of 8 equals 24. 4 multiples of 8 equals 32. 5 multiples of 8 equals 40. 6 multiples of 8 equals 48. 7 multiples of 8 equals 56. 8 multiples of 8 equals 64. 9 multiples of 8 equals 72. 10 multiples of 8 equals 80. 11 multiples of 8 equals 88. 12 multiples of 8 equals 96. 1 multiples of 9 equals 9. 2 multiples of 9 equals 18. 3 multiples of 9 equals 27. 4 multiples of 9 equals 36. 5 multiples of 9 equals 45. 6 multiples of 9 equals 54. 7 multiples of 9 equals 63. 8 multiples of 9 equals 72. 9 multiples of 9 equals 81. 10 multiples of 9 equals 90. 11 multiples of 9 equals 99. 12 multiples of 9 equals 108. A. Multiple of a number. A number is a multiple of n if it is the product of a counting number and n. Another way to say that 15 is a multiple of 3 is to say that 15 is divisible by 3. That means that when we divide 3 into 15, we get a counting number. In fact, 15 divided by 3 is 5, so 15 is 5.3. B. Divisible by a number. If a number, m, is a multiple of n, then m is divisible by n. If we were to look for patterns in the multiples of the numbers 2 through 9, we would discover the following divisibility tests. C. Divisibility tests. A number is divisible by 2 if the last digit is 0, 2, 4, 6, or 8. 3 if the sum of the digits is divisible by 3. 5 if the last digit is 5 or 0. 6 if it is divisible by both 2 and 3. 10 if it ends with 0. Example 1.1. Is 5625 divisible by A. 2, B. 3, C. 5 or 10? D. 6? Solution. A. Is 5625 divisible by 2? Does it end in 0, 2, 4, 6 or 8? No. 5625 is not divisible by 2. B. Is 5625 divisible by 3? What is the sum of the digits? 5 plus 6 plus 2 plus 5 equals 18. Is the sum divisible by 3? Yes. 5625 is divisible by 3. C. Is 5625 divisible by 5 or 10? What is the last digit? It is 5. 5625 is divisible by 5, but not by 10. D. Is 5625 divisible by 6? Is it divisible by both 2 and 3? No, 5625 is not divisible by 2, so 5625 is not divisible by 6. Try it. 1.1. Is 4962 divisible by A. 2, B. 3, C. 5, D. 6, E. 10? Try it. 1.2. Is 3765 divisible by A. 2, B. 3, C. 5, D. 6, E. 10? In mathematics, there are often several ways to talk about the same ideas. So far, we've seen that if m is a multiple of n, we can say that m is divisible by n. For example, since 72 is a multiple of 8, we say 72 is divisible by 8. Since 72 is a multiple of 9, we say 72 is divisible by 9. We can express this still another way. Since 8.9 equals 72, we say that 8 and 9 are factors of 72. When we write 72 equals 8.9, we say we have factored 72. 8.9 are the factors. 72 is the product. Other ways to factor 72 are 1.72, 2.36, 3.24, 4.18, and 6.12. The number 72 has many factors: 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, and 72. D factors. If A dot B equals M, then A and B are factors of M. Some numbers, such as 72, have many factors. Other numbers have only 2 factors. A prime number is a counting number greater than one whose only factors are 1 and itself. E-prime number and composite number. A prime number is a counting number greater than one whose only factors are 1 and the number itself. A composite number is a counting number greater than one that is not prime. A composite number has factors other than 1 and the number itself. The counting numbers from 2 to 20 are listed in the table with their factors. Make sure to agree with the prime or composite label for each number. Factors. Prime or composite. Number. 2. Factors. 1, 2. Prime. 3. Factors. 1, 3. Prime. 4. Factors. 1, 2, 4. Composite. 5. Factors. 1, 5. Prime. 6. Factors. 1, 2, 3, 6. Composite. 7. Factors. 1, 7. Prime. 8. Factors. 1, 2, 4, 8. Composite. 9. Factors. 1, 3, 9. Composite. 10. Factors. 1, 2, 5, 10. Composite. 11. Factors. 1, 11. Prime. 12. Factors. 1, 2, 3, 4, 6, 12. Composite. 13. Factors. 1, 13. Prime. 14. Factors. 1, 2, 7, 14. Composite. 15. Factors. 1, 3, 5, 15. Composite. 16. Factors. 1, 2, 4, 8, 16. Composite. 17. Factors. 1, 17. Prime. 18. Factors. 1, 2, 3, 6, 9, 18. Composite. 19. Factors. 1, 19. Prime. 20. Factors. 1, 2, 4, 5, 10, 20. Composite. The prime numbers less than 20 are 2, 3, 5, 7, 11, 13, 17, and 19. Notice that the only even prime number is 2. A composite number can be written as a unique product of primes. This is called the prime factorization of the number. Finding the prime factorization of a composite number will be useful in many topics in this course. F prime factorization. The prime factorization of a number is the product of prime numbers that equals the number. To find the prime factorization of a composite number, find any two factors of the number and use them to create two branches. If a factor is prime, that branch is complete. Circle that prime. Otherwise, it is easy to lose track of the prime numbers. If the factor is not prime, find two factors of the number and continue the process. Once all the branches have circled primes at the end, the factorization is complete. The composite number can now be written as a product of prime numbers. Example 1.2. How to find the prime factorization of a composite number. Factor 48. Solution. Step 1. Find two factors whose product is the given number. Use these numbers to create two branches. 48 equals 2.24. 48 is the product. 2 and 24 are the factors. Step 2. If a factor is prime, that branch is complete. Circle the prime. 2 is prime. Circle the prime. Step 3. If a factor is not prime, write it as the product of two factors and continue the process. 24 is not prime. Break it into two more factors. 24 has factors 4 and 6. 4 and 6 are not prime. Break them each into two factors. 4 has factors 2 and 2. 6 has factors 3 and 2. 2 and 3 are prime, so circle them. Step 4. Write the composite number as the product of all the circled primes. 48 equals 2.2.2.2.3. We say 2.2.2.2.3 is the prime factorization of 48. We generally write the primes in ascending order. Be sure to multiply the factors to verify your answer. If we first factored 48 in a different way, for example as 6.8, the result would still be the same. Finish the prime factorization and verify this for yourself. Try it 1.3. Find the prime factorization of 80. Try it 1.4. Find the prime factorization of 60. How to find the prime factorization of a composite number. Step 1. Find two factors whose product is the given number, and use these numbers to create two branches. Step 2. If a factor is prime, that branch is complete. Circle the prime, like a leaf on the tree. Step 3. If a factor is not prime, write it as the product of two factors and continue the process. Step 4. Write the composite number as the product of all the circled primes. One of the reasons we look at primes is to use these techniques to find the least common multiple of two numbers. This will be useful when we add and subtract fractions with different denominators. G. Least common multiple. The least common multiple, LCM, of two numbers is the smallest number that is a multiple of both numbers. To find the least common multiple of two numbers, we will use the prime factors method. Let's find the LCM of 12 and 18 using their prime factors. Example 1.3. How to find the least common multiple using the prime factors method. Find the least common multiple, LCM, of 12 and 18 using the prime factors method. Solution. Step 1. Write each number as a product of primes. 18 has factors 3 and 6. 6 has factors 2 and 3. 12 has factors 3 and 4. 4 has factors 2 and 2. Step 2. List the primes of each number. Match primes vertically when possible. List the primes of 12. 12 equals 2.2.3. List the primes of 18. 18 equals 2.3.3. Line up with the primes of 12 when possible. If not, create a new column. Step 3. Bring down the number from each column. LCM equals 2.2.3.3. Step 4. Multiply the factors. LCM equals 36. Notice that the prime factors of 12, 2.2.3, and the prime factors of 18, 2.3.3, are included in the LCM, 2.2.3.3. So 36 is the least common multiple of 12 and 18. By matching up the common primes, each common prime factor is used only once. This way you are sure that 36 is the least common multiple. Try it 1.5. Find the LCM of 9 and 12 using the prime factors method. Try it 1.6. Find the LCM of 18 and 24 using the prime factors method. How to find the least common multiple using the prime factors method. Step 1. Write each number as a product of primes. Step 2. List the primes of each number. Match primes vertically when possible. Step 3. Bring down the columns. Step 4. Multiply the factors.